हॉट यार. So theorem 1, everyone join as soon as possible. Ma'am, inform the student to join as soon as possible, ma'am. I don't know what is happening. I'm sweating a lot. I'm sweating a lot. You say students to join as fast as possible. Arnisha, good evening, beta. पता नहीं. I'm sweating a lot. पता नहीं. That Sam is coming? Good evening, child. Now look here. We'll go with the theorem. The perpendicular from the center of the circle to the chord bisects the chord. We will do the first theorem. The perpendicular, good evening. The perpendicular from the center of the circle to the chord bisects the chord. This theorem we are going to do. The perpendicular from the center of the circle to the chord bisects the chord. We are going to do that, okay? Kanishk, take out your note, please. Come here. Write it. मैम फैन ऑन कर लो. ऑलरेडी फैन ऑन है यार. पता ही नहीं क्या हुआ है. I just started sweating a lot. Okay, let's start the class, please. The perpendicular drawn from the center of the circle to the chord bisects the chord. Do it nicely, beta. Bisects the chord. The perpendicular drawn from the center of the circle to the chord bisects the chord. This is one of the most important concept. This is one of the most important theorem also. We need to do it. Okay. So what is the concept? The concept is, come here, Kanishk, from here study beta. The perpendicular drawn from the center of the circle to the chord bisects the chord. This is one of the most important part. So how we are going to prove this? So first work what we are going to do here is, we are going to draw the perpendicular, okay, from the center of the circle to the chord. So this is exactly the circle, okay. So in this circle, this will become the center. Now the perpendicular drawn from the center of the circle to the chord. This is our chord A and B. This is our chord AB, okay. Avni, good evening, beta. I'm fine, thank you, Avni. So the perpendicular drawn from the center of the circle to the chord. The perpendicular drawn from the center of the circle to the chord bisects the chord. So what is given and what we are going to write? Just check this one out. So given section first we are going to take. So what is the given section? The given section is a circle with center O and radius R is given. A circle with center O and radius R is given. Okay. Now what we are going to do? A circle with center O and radius R is given. After that, what we are going to do? OA is equal to OB. They are what? Radii of the circle. They are what? Radii of the circle. Now what they are asking? OD is perpendicular to AB. It is also given. OD is perpendicular. So three things back to back they have given. Yes, chord is an line segment, auntie. See, the chord what you have drawn now, the chord is exactly the line segment. The chord is the line segment. That's true only. The chord is the line segment. The chord is the line segment. So now what you are going to do here? Now please pay attention here. Whatever chord you are exactly going to draw, you need to check this one out. Now look here. So chord is exactly this one. Now what work we are going to do? So to prove that AD is equal to DB. This is one thing we must prove. To prove that AD is equal to DB. Kanishk, are you understanding this one, beta? So here, this is what you have to prove. What is given to you? The thing what is given to you is OD is perpendicular to AB. This is given. OD is perpendicular to AB. And now what we need to prove? AD is equal to DB. This is what we need to prove. So now what work we are going to do? This is to prove that, and this is given. Now we will start the proof. In circle C with center O and radius R. Also we know that OA is equal to OB radii. So in triangle AOD and triangle BOD. Now what we will do? OA is equal to OB. That is radii. This part is equal to this part. Okay. Now OD is equal to OD. This is common. Understood? And now this perpendicular is given. Angle ODA is equal to angle ODB. ODA is equal to ODB. It is also given. So what we are seeing here is this side. So right hypotenuse side. So triangle ODA is congruent to triangle ODB by RHS. Okay? By RHS, they both are congruent. Yes? Suryakala, hi. So that is exactly given. So once you have taken this part, you need to do only one work. You need to write AD is equal to DB by CPCT, corresponding part of congruent triangle. Understood? Corresponding part of congruent triangle. Corresponding part of congruent triangle. Corresponding part of congruent triangle. Is it done? So this is exactly given to you. So please pay attention here. This part is given. So AD is equal to DB. This is by CP, CT. So we have exactly understood. So these sections are there in a circle. So is this a tough proof? No. So what they're asking that, see, listen one more time. From the center of the circle to the chord, any line, can you switch off that fan beta? Any line drawn from the center of the circle to the chord bisects the chord. Any line drawn from the center of the circle to the chord bisects the chord. That both fans switch off. That is bisecting the chord. Though that is off also. Both. That is bisecting the chord. That's the most important part. Any line drawn from the center of the circle to the chord bisects the chord. So this is one of the most important thing. We must remember this one. Okay. Got it? So now we will go for the next one, please. We'll go for the next one. Done? So now next theorem we are going to do. Now we are going to study the next theorem part. Corollary part we are going to do NCERT question that day you were giving now. Give me the NCERT book beta. I am going to teach that NCERT part. And we understood? Good. Now let's see next part. See, another important point is exercise 9.1 we are going to do. First question is two circles are congruent. Okay. Now what they are telling that two circles are congruent. Two circles are congruent if they have same radii. Yes, if they will have same radii, two circles will be congruent. Prove that equal chord of congruent circles subtend equal angle at their center. Note down what they are asking. See, definitely this statement is true. If one circle is there, another circle is there. So if their radius is same, so this is OA and this is OB. So OA is equal to OB. OA and this is O dash. So two circles are there having center O and O dash. So now what we are learning here is OA is equal to O dash B. So radii of circles C with center O and radius R and C dash with center O dash and radius R are same. So radii are same. So this is exactly given. It is exactly given. Okay. Yeah, I'm going to start quadrilateral also, Yuva. Today, where are you, Yuva? Yuva Shri? Now look at it. So C dash O dash R is given. So this is exactly one part. So OA is equal to O dash B. That is radii of circle. This and this are same. Now beta, what to prove that? To prove that chords are equal. They are telling that they will be exactly prove that equal chords of congruent subtend equal angle at the center. So they are telling equal chords. So they are telling this part A is there and there we will write here C and B and we will write here D. So they are telling to prove that angle AOC is equal to angle BO dash D. This is what they want us to prove. This is what they want us to prove. So now we can very easily prove that. Quadrilateral this week itself we are going to. Okay, beta, no problem. Bhavya, where Bhavya and Shanvi is there? I need to discuss. Okay, fine. Now come on, check this one out. So now this is exactly the part is given to you. So prove that angle AOC is equal to angle B. This part we have to prove. They are telling that two different circles are there. They are congruent when their radius are equal. Two different circles are congruent when they are what is equal? When their radius are equal. What is equal, beta? Radius are equal. Two different circles are congruent when their radius are equal. So now when their radius are equal, now what next work you have to do? Our work is to prove that. So we will start with proof. We will say circle with center O and radius R, and this with center O dash and radius R are two circles. Understood? Are two circles having same radius. Are two circles having same radius. Are two circles having what radius? Same radius. Okay. So having two circles with same radius. So this part we have studied. Now what next we are going to do, beta? So these are the two circles having same radius. Done. Now what we need to prove? We need to prove first in triangle, in proof section, in triangle, in circle only we will take, in triangle AOC and triangle BO dash D. Now already we know that OA is equal to O dash B, that is radii of circle. Understood? Because both the circles are congruent. Why? Because their radius are equal. Their radius are equal. Now Kanish, what we can do here is OC is equal to O dash D. Again radii are equal. Next part is beta AC is equal to BD. Chords are equal. Chords, chords are equal. So definitely both the triangle AOC is congruent to triangle BO dash D. Then by CPCT, by side. Then by CPCT, angle AOC is equal to angle BO dash D by CPCT. Corresponding part of congruent triangle by CPCT, it is coming as equal. Note down please beta. Okay, you are no problem, beta. Not at all a problem. You take care of yourself. Yes. Hello, Craft Vidya. I hope you might have understood till here. So this is exactly the way we are proceeding. Okay. Now we will be going for the next one. This is NCRT question, exercise 9.1, question number 1, NCRT question. Good evening, Tia. Now we will go reverse and we will prove it. Now what they are doing is they are telling us to prove the reverse part of it. What is the reverse part of it, beta? They are telling that prove that if chords of congruent, you need to understand this one. What they are telling that prove that if chords of congruent angles, I'm just writing the question. This is NCRT, same pattern question. So circle we are going to keep same. Okay. So this is exercise what, beta? Exercise 9.1. Question number 2 I am giving. Okay. Exercise 9.1, question number 2, right? That two circles prove that if chords of congruent circles, I am writing the question here. Please note down if, yeah. So I am just writing, prove that if chords of congruent circle, if chords of congruent circles, if chords of congruent circles subtend substance chords of congruent circles subtend equal angle at their center, then the chords are equal. Then the chords are equal. So beta here what is given to you, beta? What and all things are given? So this is exactly given. OA is equal to this radii of the circle. This are same. because both the circles are congruent. What is the meaning of congruent circle, beta? The meaning of congruent circle is कि when both the circles are having same radius. So if two circles are having same radius length, then they will always be congruent. They will always be what? Congruent. Okay. So here we are going to take that. Now here what is given to you? Here we are just going to write two different things. So here this is given to you. Angle AOC is equal to angle BO dash D. This is given. AOC is equal to angle BO dash D. This is actually given. Now beta, what to prove? Here we will prove that chords are equal. Can you do it? See, what we are going to start with, in circles, C with center O radius R and C dash with center O dash and radius R. So now we are going to take triangle. Yes, all see, Arunisha, you need to understand here one thing, beta, that they have already given a very important point. And the most important point what they have given. So radii part is already given. So now what we need to do is, most of the things will be same. Most of the things will be same because most of the contents are same here. Only one small change you have to do. Now look here, beta, angle AOD. Please pay attention here. In two circles, these things are given. Now you check angle AOC and angle BO dash D. What is given? OA is equal to O dash B. They are radii, so they are same. Now OC is equal to O dash D. They are again radii, so they are same. Now angle AOB is equal to angle BO dash D. This is given. So that means we can say triangle AOC is congruent to triangle BO dash D by side angle side. By side angle side, they both are becoming congruent. So once they both are becoming congruent by side angle side, then by CPCT we can say AC is equal to BD by CPCT. So we have done both the questions of NCERT, exercise 9.1 and exercise 9.1, both the question 1 and 2 we have finished. So please check this one out. We have just not done very big thing, very simple way, simple technique we adopted and we solved. We just told that two triangles are there in two different congruent circles. Okay. Hi Sahil. So two different circles. After that, what we did? We told that their center angle is same. Understood? Kanish, do you understood here, beta? So this angle and this angle was same. Now, beta, this is radius because both the circles are congruent. Being congruent circle means their radius is same. Being congruent circle means what? Their radius is same. So this radius will be equal to this radius. So that means what? Radius we know now OA is equal to OC, because in a circle always the radius remains the same. OB is equal to OD also, same thing. So OA is equal to O dash B and OC is equal to O dash D. Radii we can write, and then this angle and this angle is exactly same. So that means both the triangles are congruent, side angle side. What they are exactly given? Side angle side. And by this criteria, what we are exactly judging, that AC is equal to BD. AC is equal to BD. Did you understood, beta? So now we will go for the next part. Are you ready for it? Yuvashri, you need to explain me your exam portion and when is the exam, beta, so that I can start working on your preparation. Okay? So you just have to inform me when is your examination and what in all chapters are there. Because circle 1 exercise we have just now finished. Only Euclid is coming. Which chapters are coming, you can type and send me. Now beta, another theorem. Theorem 9.6, that is equal chords of circle are equidistant from the center. This is what we are going to prove. Right, next proof, beta. That's theorem. 5, 6, 7, 8 lesson. 5, 6, 7, 8. You are also from KV? 5, 6, 7, 8. Yeah, I'll let you prepare for that. Not a problem. Not a deal. 5, 6, 7, 8. Okay. Which KV? Here, means all the KV syllabus is same. Is it okay, beta? Now look here. So definitely I'll help you. KV1. Okay. Now look here, beta. So everyone, please pay attention. Today, then next class I will be giving chapter revision. Quadrilateral I will start. Beta, just send me the time schedule, exam schedule. Exam schedule you send me. Today I just put circle. Kalpakam. Okay. So now let's see. We'll go for this. So first we are going to do the next theorem. All the theorems I am giving. Okay, beta, 5, 6, 7, 8. Now, in no time I am going to give. So you need to come, Yuva. I will be giving personal training and I will explain everything. Don't worry about that. Don't worry about exam. Last exam you have got full marks. This time also you'll get full marks. Now look here. The perpendicular from the center of a circle to the chord bisects the chord. This theorem we have done already, beta. The perpendicular from the center of the circle to the chord bisects the chord. Now the line drawn through the center of a circle. Okay, no problem. I'll help, beta. So the line drawn through the center of a circle, the line drawn, note down, this is theorem, next theorem, the line drawn through the center of a circle, the line drawn through the center of a circle, the line drawn through the center of the circle to bisect a chord the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. To bisect a chord is perpendicular to the chord. So here this is just the reverse part we are doing. Okay, from tomorrow we'll start revision. Science portion also you inform me, beta. So now look here, to prove that, so first we will draw the line drawn from the center, the line drawn through the center of the circle. So the line drawn from the center of the circle to the chord is bisecting the chord. Understood? So one line is drawn from the center of the circle to the chord. It is bisecting the chord. Now we need to prove that it is perpendicular to the chord. So our proof should be it is perpendicular to the chord. Our proof is it is perpendicular to the chord. So what we are going to write? We are going to write in given section a circle C with center O and radius R is given. Okay, what is given? AD is equal to DB. Already given. They're telling bisector. Bisector means AD part will be equal to DB. It is exactly given. Next part, what is there? OA is equal to OD. OA is equal to OB. This is radii. This is radii. OA is equal to OB. This is exactly what, beta? Radii. Now what we are going to do? We need to prove this section. So we will take in proof section, we will write in circle C with center O and radius R. In circle C with center O and radius R. See, tomorrow I am going to keep extra class, Yuva. Morning itself I will start keeping extra class. Get ready, Kanishk. So tomorrow morning I am keeping extra class and I will be exactly explaining whatever doubts are there. One by one I will start clearing the doubts better. In circle C with center O and radius R. You actually bring all the doubts better. Yes, tomorrow morning itself we'll start revision better. So here in circle C with center O and radius R. Now what we will do? In triangle AOD and triangle BOD. Now what next we are going to do? Triangle AOD and triangle BOD. Now what and all given, beta? First OA is equal to OB. What they are? Radii. Next part what they have given? OD is equal to OD. Common. Now check this one out, beta. So these two are actually common. OD is equal to OD. OD is equal to OD. This side is equal to this side. Now this is the common side for both the triangle. Now AD is equal to DB given. AD is equal to DB given. So now what is happening? Triangle AOD is equal to triangle AOD is equal to triangle BOD. By what criteria? Side, side, side. Understood? Then what is by CPCT we can say? By CPCT we can say angle ADO is equal to angle BDO. By CPCT we can say corresponding part of congruent triangle. So by CPCT what we can say? By CPCT we can say AD is equal to ADO. This now beta chord is always a line segment. Chord is always a line segment. So what we will say, since AB is a chord, since what is a chord? AB is a chord. So now angle ADO is equal to angle BDO, this proved. We have already proved earlier. Correct, no? We have proved this part. So now, since AB is a chord, which is a line segment, whenever you need to clearly write the content, you write the content to a very finishing one. Okay. Now, beta, what you are going to write? Angle ADO plus angle BDO is equal to 180 degree. Why? Linear pair. Why? Because it is on a line AB. AB is a chord which is a line segment. So this angle is equal to this angle, already we proved. We said this side is equal to this side is equal to this side, and this side is coming as common. So 100% what we did? We wrote this. So 2 times of angle ADO is equal to 180 degree. So angle ADO is equal to 90 degree. Therefore, AD is perpendicular to AB. Proof. Sorry, OD is perpendicular to AB. This is what they wanted to prove. And we have done it very clearly. See, whenever you are solving, the biggest part of ninth mathematics is circle, quadrilateral and triangle and their proof. If you will be weak in this entire your life, you will never be able to learn it properly. So you need to first understand these mathematics are very, very important to learn. The tricks has to be learned very properly. I hope you might have understood, beta. So first note down this one. A circle C with center O and radius R, AD is equal to DB given. So note down very particularly. Don't be in hurry worry. Just do the work. You understood, beta? Child, are you there in the group? So definitely this part, these theorems are most important and we are supposed to write everything because in NCRT content, this is exactly the most important part to be noted. Okay? Yes, understood, child? Okay. Very good. Now we'll go for the next one. Are you ready for the next one, please? Now look at. So this is one theorem we have done, and this theorem is very, very important when you will be discussing. Understood? So now see, I have given the full entire section proof. Very easily we have proved it. Correct na beta? Now we will go with the next proof. All the proof of circle chapter do very nicely. Okay? The next proof. Did you note it beta? Everything did you note it nicely? Now look here. We will go for the next part of the proof. Write this section. Write the section. Chords equidistance from the center of a circle. Chords equidistant from the center of the circle. From the center of the circle. Chords equidistant from the center of the circle. Note down. Chords equidistant from the center of the circle. From the center of a circle are equal in length. Are equal in length. Are equal in length. Chords equidistance from the center of a circle are equal in length. So that means what we have to prove beta, this is exactly a circle and here two chords are there. Done? So beta, they are equidistant from the center. What does this mean? Chords equidistant from the center of a circle are equal in length. So beta, this is center of the circle. This is A, this is B, this is C, this is D, this is E, and this is F. Done? Now beta, they are telling this OE is equal to OF given. What we need to prove here is this side is equal to this side. Got it? So definitely this part will be equal to this part. This is equal to this already given. Now what next we can do? Think very nicely. Yes, Yuvashri is there, ma'am. Bhavya is not there. Shanvi is not there. Come on, try this one out. Now look beta, definitely this is radii, done. This is equal to this given. Now chords drawn from the center of the circle to the chord, line drawn from the center of the circle to the chord bisects the chord. But beta, they are telling chords equidistant from the center of the circle are equal in length. Check this one out nicely. Are equal in length. This is exactly we need to prove. Are equal in length. Now look here, I'm going to prove this one. With a perfect angle, I'm going to prove it. Okay. Now first what we are going to do, we will be writing this part. Understand this one very clearly. So what is exactly AB and CD are chords. So in circle, what is given first we will write? In given we will write circle C with center O and radius R. What is given beta? AB and CD are chords. AB and CD are chords. What are AB and CD? Chords. And beta, after that what they said, OE is equal to OF. OE is equal to OF. This is given. OE is equal to OF given. This is actually given. Now what is exactly, all the radius will be equal. OA is equal to OB is equal to OC is equal to OD. They are radii. and they are equal. They are radii and they are what? Equal. So this is next important point. Now next part, what we are going to do? First we will take triangle AOB. So in triangle AOB, first you check this one very nicely. Huh? Now you need to understand that this side will be equal to this side radii. So this angle will also be equal to this angle. Correct or wrong? Because angles opposite to equal sides of a triangle are equal. Angles opposite to equal angles of a triangle are equal. Now we have this angle equal to this angle. Correct? Here also this angle will be equal to this angle. Correct? So these two sides are equal. So corresponding angles are also coming as equal. Now what next we have to do? Come on, go for it, please. Sham. Sham, I'm saying. Kanishk, come on, go for it, please. Do it. Two parts we have finished. Did you note it, beta? Just last part is there. I'm going to prove the last part. Just last section is there. We are going to prove that one, and after that, this theorem will be over. So, what work we are going to do here? Chalo, let's see. So, first work is we will take triangle. In triangle AOB, we know this side is equal to this side. Already we have learned one thing. Did you remember? We learned few factors. In that first factor is, let's see, because we need to prove only half section is equal, means a line drawn from the center of the circle to the chord bisects the chord. Understood? A line drawn from the center of the circle to the chord bisects the chord. Okay. So first work we will do. So if it is bisecting the chord, means this side will be equal to this side. And if it is bisecting the chord, means this side is equal to this side. Already this side is equal to this side radii. This is exactly given. And now this side part will become equal to this side by the concept. Understood? So now once we have done this part, this triangle will become congruent to this triangle. Understood? Or by vertically opposite angle also we can take this side, because this is intersecting. Okay, but we can't take directly vertically opposite angle. It is not going to work here. So we will take this section only. Okay, because two centers radii is exactly equal now. So we are drawing. So in triangle AOB, or we can directly write in triangle AOE and triangle DOF, OE is equal to OF. This is given. Okay. OA is equal to OD, that is radii. These two things are given. Now AE is equal to FD. AE is equal to, we will take angle only, better we will take angle. Angle AOE is equal to angle DOF. Okay, they will be equal. So now angle, side angle, and triangle AOE is congruent to triangle DOF by side angle side. Then by CPCT, AE is equal to FD. Understood? A is equal to FD. And already we know this side is equal to this side. So AE plus AE we will do. AE plus AE is equal to this part, because this is already half is there. So if half is equal, means 2 times of equal we can write 2 times of AE is equal to 2 times of FD is equal to AB is equal to CD. That's it. Note down. That is AB is equal to CD. Yes, Yuva, I got it, beta. Note down, please. So please note down the content very carefully. Study equal chord subtend, equal angle at the center. Understood? Equal chord subtend, equal angle at the center. That is one theorem. And the chords which is equidistant from that will be equal. That is another important theorem. So these theorems are very, very important and you need to learn it very nicely. Hmm. We can use the perpendicular concept also. We can say that line drawn from the center of the circle to the chord is perpendicular to the chord. That concept also we can use. That concept, without using that concept, I have exactly taken. That angle I made it equal, okay? And then we have proved. You can take perpendicular. So when you will take perpendicular, then right hypotenuse side. If you will take that line drawn from the center of the circle to the chord is perpendicular to the chord. So if you write here this part, that is line drawn from the, if you will take in the given section OE perpendicular to AB, and this is another way to prove, and OF perpendicular to CD, then proof will change. So if you will take like this, then angle OEA is equal to angle OFD will be equal to 90 degree. Then they both will be exactly angle AOE is congruent, sorry, AEO is congruent to triangle BFO by right hypotenuse side. Then directly we can say AE is equal to FT, and 2 times of that, okay, and 2 times of that will exactly make it AB is equal to 2 times of, if you will multiply this, then it will become AB is equal to CD. AB is equal to CD. So there are many ways through which we can attempt and we can solve the question. This is totally based on you, how you are interacting with the questions and how you are solving the question. I hope. Now tomorrow you are having class. Again tomorrow I am going to conduct class in the morning section. I am going to keep class. Plus we are going to study gravitation next sections, and numericals we are going to study in gravitation, because now physics and chemistry will be our total focus. Physics section will be our best focus because ninth physics is very, very important, and chemistry section also I will pay full attention so that you can be able to do good in that. Okay beta, right, next question. Equal chords of a circle are equidistant from the center. Our next proof is this one done, right Kanishk? Right, equal chords of a circle, equal chords of a circle, equal chords of a circle are equidistant, just reverse of it, equidistant from the center. Equal chords of a circle are equidistant from the center. Equal chords of a circle are equidistant from the center. This is another proof. Equal chords of a circle are equidistant from the center. I hope you might have understood. Equal chords of a circle are exactly subtending equal angle at the center. This is exactly we have to prove. So when they will be giving you that equal chords of a circle are equidistant from the center, how we are going to prove? Equal chords, ayo, this is looking like laddu only. Laddu nare? At least now it is looking like, no, perfection is missing. Perfect. Come on, draw this one out. So this is exactly two chords are there, one chord and this chord. This is center and this is coming as O. Understood? So equal chords are there. You must understand that OM and OL is there. Got it? And they are perpendicular because we can take like this and now these are the radius. Done? So we are going to draw like this. This is exactly becoming the radius. Done? So once this is the radius, now we can solve the question. Are you ready for it, please? So equal chords. So what is given, beta? So we are going to do that. A, B, C and D. Done? A, B, C, D we have written. After writing A, B, C, D, what we are going to say? E, F, G, H. Huh? So given a circle with center O and radius R, chords are equal. So AB is equal to CD. Next, beta. OM is perpendicular to AB and OL is perpendicular to CD. OM is perpendicular to AB and OL is perpendicular to CD. Okay. So this is exactly given. So what work we are going to say? Now we don't have any big work. So to prove that, what we need to prove here? We need to prove that OM is equal to OL. This is what we need to prove. OM is equal to OL. This is what we need to prove. So now proof section we are starting. In proof section, what we will do? In triangle BOM and triangle DOL. First work is what, beta? We know that chords are equal, है ना? So AB is equal to CD. This is given. Now we will do half of it. Half of AB is equal to half of CD. If full part is equal, then half is also going to be equal. So half of AB is BM. So BM is equal to LD. BM is equal to LD. This part is there. Then angle BMO is equal to angle DLO. Why? Because OM is perpendicular to AB and OL is perpendicular to CD. This is done, beta. Now once these two things are done, next part, beta. So this is already we proved that this is 90 degree, this side is equal to this. Now OB is equal to OL, radii. OB is equal to OL, they are radii of circle. So radii of circle means radius. So radii of circle. Therefore what we can say? Triangle BMO is congruent to triangle DLO by right hypotenuse side. Then by CPCT, OM is equal to OL by CPCT. OM is equal to OL by CPCT. Come on, go for it. Hi Rishabh. Hi Rohit. So this is exactly the thing we need to prove. So it is not a rocket science, very simple thing. Happy Diwali. Now happy Diwali. When is Diwali? I seriously don't know when is Diwali. I know my Diwali is on Monday. I am having my DC meeting of PhD on Monday. So my Diwali is on Monday only. That day, cracker will burst on my head. Prak, 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 prak. She will put bomb on me. My HOD will put bomb on me that day. For me, Diwali is on Monday only. Okay, come on, jokes apart. This is equal to this. This is 90 degree and this side is equal to this one. Now it is coming na beta. So half of this is equal to this. So we will say this, that this side is equal to this side. This side is equal to this side. Correct? Last which one beta? This is 90 and this is 90. So right hypotenuse and side. Both the triangles are congruent. For you, Diwali is on Sunday. My Diwali is on 13th of month, 13th of October. Monday. My research department will specifically put bomb on my head and they'll bust crack a doom. That is my Diwali. Not preparing, roaming here and there. Today night I'm going to sit for preparation. So that's it for today. How many theorems we did, beta? How many questions we did today? One, two. Hey, you did not wrote. Monkey. Okay. Bye everyone. Tanisha is not there. Bye everyone.